Equations. Alright, so here we have two parts, right? Two equations that we're trying to solve. This first one, we can see there's an x squared term, and that's the highest power. So we know that this is a quadratic equation. So how many solutions would we expect in solving a quadratic equation? Right, we'd expect two. Just a reminder, a parabola or a quadratic graph usually intercepts the x-axis twice, right? So when we set a quadratic function, such as this one, equal to 0, we're saying what values of x is the y value equal to 0. In other words, these x-intercepts, or in this case, solving for x. Maybe back in year 11 or year 10, you would have approached this by making a guess and then checking it. So we could guess, right, I guess x equals 2. And then we substitute in 2 in for x to see if this equation holds true. And that just means that the left side does equal the right hand side. So let's just try that for fun. So 3 times 2 squared minus 6. Does that equal 7 times 2? Right, so I just substituted in 2 for x. So this would be 3 times 2 squared, which is 4, minus 6 equals 14, which is 12 minus 6, which is 6, which does not equal 14. So what we've done is we've shown that x equals 2 is not a solution. Now, that's not really helping us exactly, so let's try a more algebraic method in solving this. If we have a quadratic equation, a very good approach is to bring everything to one side. So I'm going to take the 7x to the left-hand side by subtracting 7x from both sides. And to be consistent, I'm going to just put the 7x term in the middle, so it looks a bit more familiar. Right, and we call this standard form. So we have the x squared term, the x term, and then the constant. And so this is our quadratic equation. And to solve this, we could factorize it. We could use the quadratic formula. We could complete the square. We could use polysolve on our calculator, or we could graph it. So it's really up to you. In this case, it's not too hard to factorize it. So we know we need 2 sets of brackets. Usually we just have x and x here, but notice the x squared term has a 3 in front of it. So the only two numbers that multiply to a 3, or two whole numbers, would be a 3 and a 1. So I'm going to just put 3x and x, because when we expand that out, we'd get 3x squared. And now we need to think of two numbers that multiply to -6. So I could think of 2 and -3, or -3 and +2. And let's just try these ones out. So if we put -3 here and +2 here, and we expand it out, so we're just checking now, we get 3x squared. We'd get 3x times +2, which is +6x, minus 3 times x minus 3x, minus 3 times +2 plus 6. And that becomes 3x, which is not minus 7x, right? That's what we were trying to get it to equal, those two terms, which tells me we picked it the wrong way around. So let's try that again. This time +2 in this bracket, minus 3 in this. And notice it changes because this 3x is multiplying. It has more weight to it on the number that we choose in either bracket. So let's expand that out. 3x squared minus 9x plus 2x minus 6. All right, and when we combine those, that is minus 7x. So we're correct in our factorizing, but it asked us to solve, not to factorize. So to solve this, we set both brackets equal to 0, because for something times something equals 0, one of them must be 0. So that gives us 3x plus 2 equals 0, or x minus 3 equals 0. And now to get x, we're just solving a simple linear equation, right? We've boiled the problem down to a linear equation. So for this one, we'll subtract 2 on both sides, and then we'll divide by 3 on both sides. So x could be negative 2/3. On the other side, other equation, we will add 3 to both sides. So our solutions are x could be negative 2/3, or x could be 3. And if you're unsure, do just pick one and substitute it in for x to show that the left-hand side does equal the right-hand side. Right? It takes less than 20 seconds, and then you'll know you're right. Another way you could solve this is using your calculator. So let's do that now. Again, this is a good way to check. So we go menu, equate for equation. We're solving a polynomial, so f2. It is degree 2, so highest power of 2, x squared. And at the start, we wrote it in this form, and that lets us very easily read off the a term, the b term, and the c term. So a is, see in our calculator at the top there, ax squared plus bx plus c. A is 3 in this case, b is negative 7, it needs the sign, and c is negative 6. And then we hit F1, which is solve, which gives us 3 and negative 2/3. Exactly what we got. So in an algebra exam situation, getting to this quadratic equation is the key step, and then how you solve it, that's up to you. Alright, part 2, we have some algebraic fractions here. I noticed that the denominators are x squared and x. So a quick way to simplify this problem would be to multiply everything by x squared. And that effectively eliminates the denominators. So let's do that. So 3 over x squared times x squared. I'll just write it out in full, but we'll see it simplifies nicely. 4 over x times x squared. And don't forget, if we multiply things on the left side by x squared, we need to also multiply things on the right side. And now 3 over x squared times x squared, the x squareds cancel, and we're left with 3. Plus, over here, we can just extend that fraction line there. X squared divided by x is x, so we're left with 4x. And of course, on the right hand side, we're still left with 5x squared. Now looking back at the first question, this looks kind of similar, right? We have an x squared as our highest power, so what we can do is bring everything to the right hand side, or the left, doesn't really matter. So we have 5x squared, and we'll subtract 3 plus 4x, so minus 4x minus 3 equals 0, right? Because I took this from both sides, meaning one side will be left with 0. And again, I wrote it in the form ax squared plus bx plus c equals 0, so that we can then solve it straight away. This time, I'll just use my calculator, save us some time. So a is 5, b is negative 4, and c is negative 3. Hit solve, and we get x equals 1.27, or x equals negative 0.47. And in this case, we would have struggled to factorize it, because it doesn't factorize as nicely as part 1. So if you try factorizing, you get a bit stuck. There's no shame in resorting to our calculator just to see what we expect. And then if it's easy enough, you could give a go at factorizing. If it's some weird decimal numbers like these, we'll just stop there.